Okay, this is our last topic for algebra, so we are going to do systems of equations. We want to solve, there's three methods that I'm going to show you to solve: graphing, substitution, and the elimination or addition method. So we're going to start by graphing. And so if you want to solve by graphing and you have a system of equations, we're only going to do two variables, two equations. And I typically number these. I didn't on the graphing ones on the notes that I wrote out, but typically I'll number them so that I can refer to them as equation 1 and equation 2, just to make it a little bit easier. But anyway, so if you want to solve by graphing, what I generally do is I'll solve both equations for y so that you get it in the y equals mx plus b slope-intercept form. That way you can graph it quickly. You're also free to graph using intercepts or however you want to, but typically I'll just solve for y. So if I solve the top one for y, I subtract x over, so I have y equals negative x plus 4. And if I solve the bottom, equation 2 for y, I subtract x over, so I get y equals negative x. And so then for my top, my slope, m is negative 1, and my y-intercept is 4. And for the bottom, my slope is negative 1 and my y-intercept is 0, 0, 0. So if you notice here, they have the same slope, but they have different y-intercepts, so they're going to be parallel. So this is actually going to be no solution. But if we go ahead and graph that, we have, I'm going to draw a graph here. For the top one, my slope is negative 1, y-intercept of 4. So I'm going to go up to 4. So there's 4, slope's negative 1, so I go down 1 over 1. Down 1, right 1, I should say, or up 1, left 1. And there's that line. And so that's line 1, or you can label it y equals negative x plus 4 if that's what you want to do. And then for y equals negative x, I start out at 0, and I go down 1, right 1. And draw that line, and they should look about the same slope-wise for parallel lines. I'm not always the best, but that's line 2. And again, that's why I usually number them. But anyway, so there's line 1, there's line 2, and so they have the same slope, different y-intercept, so they are parallel, so there is no solution. And so you would also say, you can also say that they're inconsistent. If you see that word inconsistent, it means there's no solution. You can just say no solution though if you want. So for number 2, we have 4x plus y equals 9. Sorry, the dog heard me talking back here with the door closed. She thinks I'm a stranger. Negative 3x plus y equals 2. So again, I'm going to solve for y for both of these. So if I solve the top one for y, I'm going to subtract my 4x over. So I'm going to have negative 4x plus 9. And if I do the bottom one for y, I'm going to add 3x. So I'm going to have 3x plus 2. And then I'm finished. So my top is going to be slope. My first line is negative 4. Y-intercept is 9, so the 0.09. And for the bottom, my slope is 3, and my y-intercept is 2. So I'm going to graph both of these lines. So if I draw my graph, I'm going to go, for my first line, I'm going to go up to 9. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, I think, yeah. And slope's negative 4, so I'm going to go down 4. So 1, 2, 3, 4, and then right 1, which puts me there. And I'm going to draw this line. As good, whoops, I missed, that's okay. As good as I can here, make a point a little bigger. And for the second line, so that's line number 1. For my second line, I'm going to do slope of 3 and y-intercept of 2. So I'm going to go up to 2. There's my 2, and I'm going to go slope of 3, so I'm going to go up 3 and over 1, which puts me at that same spot. And so that is my second line. So this is the point here, 1, 5, because if here's 2, 3, 4, 5, so this is 5. So this is where they intersect, so therefore that is the answer. So my answer would be 1, 5. And you can check these, of course, plug them in. 4 times 1 is 4, plus 5 is 9. That one checks. And then plug it in here. Negative 3 times 1 is negative 3, plus 5 is 2. So that does check out. So you can always check your answer when you're finished. And just to show you what it looks like if you have infinitely many solutions, we have x plus y equals negative 3 and 4x plus 4y equals negative 12. So if you notice, this is a multiple of this, but if you don't really pay attention to that and you just go about solving by graphing just like always, we're going to solve the top for y by subtracting x, so I'm going to say negative x plus 3. And then for the bottom, I'm going to subtract 4x, so I've got 4y equals negative 4x minus 12. And then I have to do one more step, I have to divide by 4. So I've got y equals negative 4 divided by 4 is negative x, and negative 12 divided by 4 would be minus 3. So if you notice here, they're the same line. They both have a slope of negative 1, and they both have a y-intercept of negative 3. So if they are the same line, so if I draw this here, just go down to 3, or down to negative 3, I mean to say, and my slope's negative 1, so I can go whichever way you want to go here. And draw your line. That's line 1 and 2 because they're the same line, right? So if you draw your line here, since they are the same line, you would say that they are dependent because it depends, like y depends on x. I can pick whatever I want for x. I can plug in a 0, I can plug in a 1, I can plug in a 0.2, I can plug in a negative 1,567.6789 or whatever. Whatever you want to pick for x, as long as you do negative x minus 3, then you'll have a solution because that's what y is. So this would just be infinitely many solutions. And you can write it as an ordered pair. I didn't write it out on the notes, but you can do, I've had people prefer doing this. X, y is x and then negative x minus 3. So like I was just saying, whatever you plug in for x, as long as you use this y, it's going to work. If you have one like this on the homework, if you just say infinitely many solutions, that's fine. But it is dependent because it depends on what you pick. So that's to solve by graphing. Now the other way, another way you want to solve is by substitution. So if you want to solve by substitution, and typically people that in my experience, most people prefer one method to another. I don't like graphing only because sometimes it's hard to tell where they intersect. So I generally pick substitution or the elimination or addition method. So here we're going to solve by substitution. So what we want to do is you want to first solve one equation for one variable, and it doesn't matter which one you do. For this one, the second equation is already solved for y. And so what we want to do is substitute this y into this first equation since it's already solved. That makes it the easiest. So we're going to say 3x plus 2 times y, which is negative 3x plus 6, is equal to 9. So we subbed equation 2 into 1, and then we just solve. So we've got 3x, and if we distribute my 2, I've got minus 6x plus 12 is equal to 9. 3x minus 6x is negative 3x. If I subtract 12, I get negative 3, and x is 1 when I divide by negative 3. So this is the x answer. Now I have to remember to go back and find y, and you can plug it into either equation 1 or equation 2. Generally I use the one, if I've solved for a variable, I'll just use that equation, or if it's done it for me, but there's no law that says you can't go plug it in 3 times 1 plus 2y equals 9 and solve that. It's totally up to you, but I'm going to plug it in here, so I'm going to use equation 2. Y is negative 3x, which we just found to be 1, plus 6, so y is 3. So my answer is the 0.13, or the ordered pair, 1, 3. And again, you can check it. It will work. So if you plug in here, we just did this, negative 3 times 1 plus 6 is 3. And then up here, 3 times 1 is 3, plus 2 times 3. 2 times 3 is 6. 6 plus 3 is 9. So it does work. So you can always check. So for number 5, we have negative 3x plus y equals negative 4. And 2x plus 3y equals 10. Okay? So again, if you don't have, if one of them's not solved, so we don't have x equals or y equals, so we need to pick one and solve for the variable. So you can pick number 1 and solve it for x or y. You can pick number 2 and solve it for x or y. Generally, if there's a variable that has a coefficient of 1, I'll pick that one. So I'm going to solve this for y. And so I'm going to say y equals 3x, if I add 3x to both sides, minus 4. And then I'm going to take this and I'm going to substitute it into the second equation over here. If you had picked the second equation and solved for one of these, then you would plug it into the first equation, whichever one you solve for, whether it be x or y. But, so I'm going to say, okay, now I've got 2x plus 3 times y, which I just found to be 3x minus 4, is equal to 10. And then I solve, distribute my 3, so I get 9x minus 12 is equal to 10. 2x plus 9x is 11x. If I add 12 to both sides, I get 22. So divide by 11, I get x is 2. That's not all though. Remember to go back. You can plug x is 2 into the first equation. You can plug it into the second equation, or you can plug it in over here. Since we solved for y over here, you can plug it in here to find y. So it doesn't matter which one you do. Just pick one. I typically will use this one. So y is 3 times 2 minus 4, so y is 6 minus 4, which is 2. So our solution is 2. Again, you can check. Negative 3 times 2 is negative 6, plus 2 is negative 4. That checks. 2 times 2 is 4, plus 3 times 2 is 6. 4 plus 6 is 10, so that works. And just to show you on substitution how it looks if you have, I think I do one of each, no solution and, one of each. If you have a no solution or an infinitely many solution. Excuse me. Okay, so here I'm going to pick one of these. None of them have a coefficient of 1. None of them are solved for me, so it doesn't matter what you do. Typically, if none of these have a coefficient of 1, I'll pick the one with the smallest coefficient and go with that. But, you know, it really doesn't matter. So I'm going to solve this for x. So we have 2x is equal to, if I subtract 3y, negative 3y plus 2. And then divide by 2, I'm going to have x is equal to negative 3/2 y plus 1. Once I've solved for my variable, so in this case x, I'm going to plug it into the other equation over here. So I've got 4 times x, which I just found to be negative 3/2 y plus 1, plus 6y is equal to 2. And solve. 4 times negative 3/2 is negative 6y. 4 times 1 is 4, so 4 plus 6y is equal to 2. And then you see negative 6y plus 6y cancels, and I'm left with 4 is equal to 2, which is not true. Therefore, there is no solution. If you get a false statement, it is no solution. If you get a true statement, it is infinitely many solutions. which is the way the next one goes. So just so you can see how that looks. If I want to solve x plus 2y is equal to 3, and then 2x plus 4y is equal to 6. So again, if you notice, this equation is a multiple of this equation. If I multiply this equation by 2, this is what I get. So when you notice that, they're going to be the same line or infinitely many solutions. But anyways, to prove that by substitution, I'm going to solve, in this case, I'm going to solve for x and number 1 again, just because it has a coefficient of 1. So I'm going to subtract 2y. I got negative 2y plus 3. And I'm going to take this and I'm going to plug it into my second equation down here. So I've got 2 times x, which I just said was negative 2y plus 3, plus 4y is equal to 6. And then solve. If I distribute my 2, I get negative 4y plus 6 plus 4y equals 6. Negative 4y plus 4y goes away. I get 6 equals 6. This is a true statement. So since it is a true statement, I would say that there are infinitely many solutions. Again, that's dependent. You can solve, in this case, I've solved for x. So I've made x dependent upon y, but you could back up and solve it for y and make y dependent upon x if you wanted. But anyways, if I pick a y value, 0, 1, 1 million, 0.999999999, whatever I put in here for y, as long as I use negative 2y plus 3, then the x will work. So I got a true statement, so therefore there's infinitely many solutions. Okay, so for your last method, you have, I still refer to it as the elimination method, and I guess it's because I learned it that way when I was in school, and now some people refer to it as the addition method. I don't care if you add or subtract. When you do this, if you are comfortable subtracting and don't lose negatives, that's fine. If you prefer always adding, that's fine. I think a lot of people have tried to switch over to just adding, so on the notes, I always multiplied through by negative if I needed to, so I could add, but anyways, I'll show you here in a second. Okay, so we want to solve 3x minus 5y equals negative 4, and negative 4x plus 5y equals 2. So you can solve by substitution, you could graph, but if you want to solve by, oh look, I just wrote down elimination, addition method. If you want to solve by elimination or addition, the reason they called it elimination is because you want to eliminate a variable. So I want to either add these, I want to subtract them, I can multiply both equations by numbers if I need to in order to make them disappear, whatever. I want to get rid of a variable. So this one is set up easy to do because you've got a negative 5y and a plus 5y. What happens if I add negative 5 and 5? They cancel out. So I'm going to add these two equations together, which is a legal move in math. You can add equations, that's fine. So 3x plus negative 4x is negative x. Negative 5y plus 5y is gone, which is what we want to happen. We want to eliminate it. Negative 4 plus 2 is negative 2. So divide by my negative, I get x is 2. So then to find y, I have to sub x is 2 back into one of these and solve for y. And it doesn't matter if you use the first equation or the second equation, either one will work. So I used the first one on the notes that I wrote, so I'll use the second one for this one. So negative 4 times x, which is just 2, plus 5y has to equal 2. So I have negative 8 plus 5y is 2. If I add 8 to both sides, 2 plus 8 is 10. So y is 2 when I divide. So the solution is 2, 2. I don't know why I make 2's different all the time, but anyways. And you can check this. Negative 4 times 2 is negative 8. Plus 5 times 2 is 10. Negative 8 plus 10 is 2. That works. 3 times 2 is 6. 5 times 2 is 10. 6 minus 10 is negative 4. That works. And so you can subtract these if you needed to. Like let's say if this had been positive and this had been both of them positive, instead of adding, I wouldn't want to add because then I'd have 10y, and I don't want to do that. I want to get rid of it. I can subtract, but what a lot of people do now is instead of subtracting, they multiply 1 by a negative and rewrite it and then add, which is fine, but you know, you can stick a minus sign out here as long as you did 3 minus negative 4, which is actually 3 plus 4 would be 7. So you just have to be careful. So if you prefer to multiply through by the negative so that you always add, that's fine. So most people prefer getting opposite signs, so then they don't forget, because that was usually the mistake, is if you wrote a minus out here, you would just look and do 3 minus 4 or something like that and get negative 1. But if this is a minus, it's minus a negative. So I just wanted to make note of that, just so you're careful and pay attention. And we're going to do one here in a second where I do multiply by the negative. So for this one, you have 3x plus y is negative 4, and 5x minus 2y equals negative 14. So 3 and 5 doesn't go away. 1 and negative 2 doesn't go away if I add or subtract, for that matter. So what do I want to do? I want to pick a variable to eliminate, right? The easiest thing to do, so 3 and 5, I could eliminate x. I could turn this into 15. I could multiply this one by 5, and I could multiply this one by 3, and I could make one of those negative so that I have all opposite signs. But it's easier to get rid of y because I have a coefficient of 1. So just like with substitution, if you have a variable that has a coefficient of 1, it's the easier one to work with, because how do I get rid of a negative 2y? I need to be able to add a 2y. This is already positive, so all I have to do is multiply this top equation by 2, and then it will disappear when I add it. So 2 times 3x is 6x, 2 times y is 2y, and 2 times negative 4 is negative 8. I'm not going to do anything to this bottom equation. I'm just going to leave it alone. So I just write it down again. So now if I add, I get 6x plus 5x is 11x. Positive 2y minus 2y, gone. That's what I wanted it to do. And negative 8 plus negative 14 is negative 22. So x equals negative 2. You'll notice a lot of the answers are 2's just because then the math's easier. But anyway, so x is negative 2. So now I have to find y. I go do that by plugging negative 2 in for one of these equations. I either plug it into 1 or plug it into 2. And so if I use 1, I have 3 times x, which is negative 2, plus y is negative 4. So negative 6 plus y is negative 4, so y is, if I add 6, 2. So negative 2, 2 is the answer. And you can check it again, it will work. Okay, number 10, we have x minus 11y is equal to 17, and 2x minus 22y is equal to 4. So again, if I want to get rid of a variable, if I want to eliminate one, I look, if I add them or subtract them, none of them will go away. So I'm going to pick one. Now in this case, you'll probably be like, well, I'm going to get rid of both of them, but that's okay. We'll talk about that in a minute. So let me just look at x because it has a coefficient of 1. So in order to get rid of a 2x, I need to either subtract 2x or add negative 2x. So this is where I was saying I'm going to, I did it by a negative 2 on the notes, which is fine. Let me do it with a positive for just a second, just so you can see something. And then I'll switch it. So if I multiply by a positive 2, 2x minus 22y equals 34. And then I didn't do anything to the second. Right? I can write subtract out here. 2x minus 2x, gone. Negative 22y minus negative 22y. So that's actually negative 22y minus a negative, which is a positive. So negative 22y plus 22y, gone. 34 minus 4 is 30. That's fine if you want to do that. What you'll mostly see now, though, is that people multiply by a negative 2, which makes this a negative, this a positive, and this a negative. And then instead of a minus, they'll add. Either way, you get the same answer. Negative 2x plus 2x is gone. 22y plus negative 22y is gone. So you still have 0 over here. Negative 34 plus 4 is still negative. Wait a minute. Negative 34. Oh, it's still negative 30. Before, if we did 34 minus 4 is 30. But regardless, you get a false statement, right? Because you have, if I did a positive 2 times 17 is 34. And if I subtract, 34 minus 4 is 30. 0 still does not equal 30. If I do it with a negative, I have negative 2 times 17, which is negative 34. Negative 34 plus 4 is negative 30. Still false statement. 0 does not equal negative 30. So either way, I get a false statement, which is no solution. Okay, so it's up to you if you want to multiply by a negative and add, or if you want to subtract. I really don't mind either way. So I'm going to skip to number 12. And we have 2x plus 8y. 8y equals 10, and 3x plus 12y equals 15. Okay, so for this one, again, if I look, 2x and 3x I can't do anything with, 8 and 12 I can't do anything with as is. So if there's no coefficient of 1, what I usually do is I pick the ones that have the smallest coefficient if it's all possible. So 2 and 3 here. I can turn 2 and 3 into a 6. I turn 2 into 6 by multiplying by 3, and I turn 3 into 6 by multiplying by 2. And again, if you want to multiply 1 by a negative, it makes no difference which one you do. So this one will multiply by 3, this one will multiply by 2. On the notes that I did the top one a negative, so I'll make this one a negative this time, just so you can see the difference. But it makes no difference, just pick one to be negative so that you switch, that you have opposite signs so you can add. Or you can leave them all positive and subtract, like I said, it doesn't matter. So you've got 3 times 2x is 6x, 3 times 8y is 24y, and 3 times 10 is 30. For the bottom, negative 2 times 3x is negative 6x. Negative 2 times 12y is 24y. Whoops, negative. I'm talking about watching your negatives and I messed up. Negative 24y. And negative 2 times 15 is negative 30. So now I'm going to add. If I add this, 6x plus negative 6x is gone. 24y plus negative 24y is gone. So I have 0 equals 30 plus negative 30 is also 0. That's true statement, which means we have infinitely many solutions. Now, if you didn't multiply one of these by a negative, let's say I did this by 3 and this by 2, I would have 6x, they would be the same. Oops, not 3x. Get it together here in a minute. 3x plus 24y equals 30. So if I did not do a negative, if I just did 3 and 2, positive, then when I would subtract, I'd have 6x minus 6x is gone. 24y minus 24y is gone. I'd have 0 equals 30 minus 30 is still gone. So I get the same answer if you don't do the opposite, if you don't multiply 1 by a negative so that you can add. But like I said, I don't want to tell you to always switch the signs because some people just prefer to subtract, and that's fine. I've thought about just quit talking about it, but I just want to make sure people pay attention to the negatives if they subtract. But you see, you get the same answer regardless. Okay, for the last one here using elimination, we have 2x plus 4y equals 3 and 3x plus 3y equals 2. Okay, so again, I can't get rid of anything the way it is. So I've got a 2 and a 3, I've got a 4 and a 3. So personally, I'll pick the 2 and the 3 over dealing with the 4 and the 3. 4 and 3 you'd have to turn into 12. 2 and 3 you can turn into 6, just like we just did. So we're going to do this one to make it a 6, I multiply by 3. And this one to make it a 6, multiply by 2. And again, we're going to make one negative. I did the top one, so I'll do the bottom one this time. So when I multiply this by 3, 3 times 2x is 6x plus 12y equals 9. When I do the bottom one by negative 2, I've got negative 6x minus 6y is equal to negative 4. Okay, so then I'm going to add, since I did multiply by the negative to get the opposite signs, I'm going to add 6x plus negative 6x is gone, which is what we wanted. 12y plus negative 6y, 12 minus 6 basically is 6, so 6y is equal to 9 plus negative 4, so 9 minus 4 is 5. So divide by 6, y is 5/6. So if you notice on the other one where I multiplied the top by a negative, I got negative and negative, so when I divide it, I still get the positive number. So you see you get the same answer, even if this doesn't say exactly the same thing, like we were talking about a minute ago with the fault statement. It was still a fault statement. So y is 5/6, so now I pick 1 or I pick 2, whichever one I want to use to find x. So I'm going to plug it into 2. So I have 3x plus 3y, which is 5/6, is equal to 2. So if I solve that, I get 3x plus 5/2 is equal to 2. 3x is equal to, if I subtract 5/2, I get negative 1/2. Divided by 3, I get negative 1/6. So my answer here is, oops, it's not that, it's x first. Negative 1/6, comma 5/6. And you can check it, it does work. So for this last part here, we're going to solve using your method of choice. It's the application question. So if you prefer graphing, if you prefer substitution, or if you prefer the elimination addition method, whichever method you prefer. So number 14 is a problem where you sum of two numbers. It's pretty self-explanatory, I think. So I'm going to do number 15, and I'm not going to write it all out here. I'm just going to kind of read it to you. So you got, I can't get it on the screen here. A play was attended by 342 people. The admission for adults was $1.50 and children 75 cents. How many adults and children attended the play if the total admission collected was $399.75? So there's your statement. And if you want to use X and Y, you can. I usually relate it to the problem. So my A is my number of adults, and C is my number of children. Okay, so it tells me two things. It tells me how many people attended total, adults and children combined. It also tells me about admission and how much admission I collected. So if I add the number of adults and the number of children, I should get the total that attended. So A plus C is 342. If I take the admission cost, so $1.50 for adults. So how much I earned off adults is 1.50 times A. If one adult came, I got $1.50. If two came, I got $1.50 times 2. If 3 came, I got $1.50 times 3, and so on and so forth. Plus, I have 75 cents for children. So if I get one child, I get 75 cents. Two child, 0.75 times 2, and so on and so forth. That has to give me my total admission, which it tells me is $399.75. So there's my system of equations. And you can pick, you want to use elimination, that's fine. If you want to use substitution, you can use substitution. I did elimination on this one, and I would do substitution now, except I forgot to bring anything back. I didn't write it out to make sure I have the numbers all right. So I'll just do elimination like I did. So if I want to eliminate a variable here, I'm going to eliminate C. So 0.75, I can turn this into 0.75, a negative, so I can add. So negative 0.75. So I've got negative 0.75A minus 0.75C is equal to 342 times negative 0.75 is negative 256.5. And then I didn't do anything to the bottom equation. And then I'm going to add. You could also subtract if you multiplied through by a positive, but I think I've harped on that enough. So negative 0.75 plus 1.5 is 0.75A. Negative 0.75 plus 0.75C is gone. And then negative 256.5 plus 399.75 gives me 143.25. And if I divide by 0.75, I get 191. So there was 191 adults, which means how many children were there? So go over here and pick one to substitute into. If I number these again, I'm using number 1, 191 plus C is 342, so C is 151. So there were 191 adults and 151 children that attended that play. Okay, and like I said, you could solve that by substitution if you wanted. You'll get the same answer. For the very last one here, number 16, these are always fun sometimes. You've got a chemistry student needs 22 milliliters of a 38% acid solution. She has two acid solutions, A and B. Acid solution A is 40% acid and solution B is 30% acid. How much of each solution should be used? So, again, if you want to use X and Y, that's fine. I used A and B. I guess I could have even used that capital A and B, but anyways, A is the amount of solution A, and B is the amount of solution B. So the easiest one to come up with is that if I add the two amounts together, that has to give me my total amount, which is 22 milliliters. The next one it tells me, it talks about percentages, right? So I want my 22 milliliters to be 38% acid. My A is 40% acid and my B is 30% acid. So if I have 0.4 A, that's 40% acid. So if I have 1 milliliter, I've got 40% acid. If I've got 2, I've got 0.4, I've got 40% of 2 is acid. If I've got 10 milliliters, I've got 40% of 10 that's acid, and the rest is whatever else is in the solution. Plus my B is 30% acid, so 0.3 times B. Again, if I've got 1, it's 0.3 or 30% acid. If I've got 2, it's 0.3 times 2, or 30% of 2, or so on and so forth. That has to equal 38% of the total volume, which is, you want it to be 38% acid, and we want it to be 22 milliliters. So the acid in A plus the acid in B has to give me the total acid and the total amount, which I know the total amount is 22. So it has to give me 0.38 times 22. So usually this is the part that throws people, but I want 38% in my 22 mLs to be acid. So essentially I want 8.36 milliliters to be acid, and then the rest of it to be whatever else it's mixed with. So then I'm going to solve this. So I've got, here's my equation 1, here's my equation 2. I'm going to solve this by substitution. So I'm going to solve the first one I'm going to solve for B. So B is negative A plus 22. And then I'm going to substitute that into the second equation. So I have 0.4A plus 0.3 times negative A plus 22 is equal to 8.36. Distribute 0.3, I get minus 0.3A plus 6.6 is equal to 8.36. 0.4 minus 0.3 is 0.1A is equal to, if I subtract 6.6, I get 1.76, so A is 17.6. So I need 17.6 mLs of solution A, And to find B, I need B is negative A, which is negative 17.6 plus 22. So B is 4.4. So I need 4.4 milliliters of solution B. And that'll give me 22 mLs total, and it'll be 38% acid. Okay, so that's all for systems. If you have any questions on anything, please let me know.